Yaskawa. You're watching the IEC 61131 Basics video tutorial series. The topic of this video is Program Data Transfer. Hi, I'm Matt Pelletier, and at this point in the training, you've used download changes many times, and you've performed that sequence of make, download, and warm start also quite a number of times. But in this video, I would like to explain the details and the options involved, considering the implications to the power on sequence and project storage for a real controller installation. Let's start off by looking at the make key, the F9 make key. What is that doing? I think we've mentioned it. Let's look at it in detail. Make does a few things. It first saves the project source, but it compiles the changes only. And the reason it does this is because it's faster than to compile the entire project every time. So make is normally what you'll do if you're planning to restart the controller after downloading. You'd start with a make, and so we're calling this the normal usage. You hit F9, and it's taking the source that it just saved, that's your project source, pulls it into the software, and then creates what's called machine code. This machine code will be able to be used by the PLC. There's another option under the build menu called rebuild project. And this is very similar. It saves the project source, but it compiles the entire project, and for this reason is a bit slower. So you may want to use rebuild project from time to time if it seems that there may be some issue with make. Sometimes using rebuild project helps shake that out. But in all cases, this does what we call compiling the project and puts that project not on the controller, it puts it into your project folder in Windows. From time to time, I'm sure many of you have gotten errors in compile. So compile does not always return an OK. Let's go through and simulate this particular error. It seems to be common. It's an easy one to generate. We will go to delete number of cars from the global list. And so if you're missing a global variable, you get this error. So just to demonstrate that, let's go to global variables. And we've got a variable like G number of cars, which we know is used in other programs. If I just delete it and then click make, I have these two errors. It says no matching global variable found. And I would like to point out, if you haven't noticed it yet, you can double click right on the error and see that it brings up, it says here I'm in the money POU, money V. So the POU called money is using G number of cars, and then this other one is the POU main V. The variable list in main is also using number of cars, and there is no matching global variable found because I deleted it. Of course, to recover from that, there are several ways. I could Control Z, I could undo the damage I just did, or I could go into any of the code pages using F5 or double clicking here, click OK, and that will put it back into the global variable list again. And so now let's do a make, and my errors have been resolved. And now what do we do after a successful make? We would normally go to the project control dialog, which pulls up the resource window. And the resource window is called that because it literally is your window into the resource. The resource is your controller. So this is your communication window into that controller. It's a communication channel. And I think we know from experience that our normal status is this green state of run. You can also stop, and the state will be stop. If you ever see the error button in red, you need to click it and resolve the error. And when this window is open, it's like it has a communication lock on the controller, and it does not allow anything to be changed. They call that a COM channel. And so it's a good idea that you close this window whenever it's not in use. And I believe I've demonstrated that very regularly here in all the videos up to now. It's the job of the resource window and the subsequent button pushes that bring up the other windows to load parts and pieces of the project into the controller, whether it's a real controller or the simulator that we're using here for this training. And so we have often clicked the download button, and then we've just clicked the download button again. But in this part of the training, let's look at what the different items are that can be sent to the controller. There are 3 items. There's the project, boot project, and sources. Up to this point, we've been downloading only the project. The project is the machine code that is downloaded to the RAM of the controller. And in order to do that download, you need to stop the CPU because the controller is using that RAM to run the current program. The boot project is also the machine code, the compiled machine code, the result of the make, but it is stored instead into the flash of the controller and is never used directly. Instead, it's loaded from flash to RAM when the controller powers up, and then it executes what's in the RAM. It's basically a copy of the project stored to non-volatile memory. So with a real PLC, what would happen if you don't check this boot project? What would happen when you reboot the controller? Well, when you reboot the controller, it would either have nothing and the controller would not run the project that it had before, or if you had an older boot project from some time earlier, it would overwrite your updated project with the old boot project. So it's usually a good idea to check this boot project for a real PLC so that you don't have that possibility. But as I mentioned here, it does take some time and you may want to uncheck it as you're doing your code development just to save a few seconds every time you download. The third item was sources. And sources means your entire project folder will be zipped into one file called zip file and will be stored on the flash of the controller. This way you can, in the future, upload the whole project back into MotionWorks IEC. Even if you've lost your PC's project, it's possible then to store it on the controller, upload it, and continue developing or monitoring whatever you want to do. It's just another copy of the project, as if you had saved it on a USB flash drive somewhere. Now, the problem with this is that, number one, it is much more data, and so it can be very slow. It also takes up a lot of the flash memory, and so there may not be room for it at all. And another issue is that of intellectual property. There may be times where the project should not be stored on the controller. Depending on the business arrangements of the parties involved, there may not be an agreement to include the editable project on the controller. It's like having the source code for any program. When you buy the program, you're buying the operational program. You're not buying the right to have the source and see how it was created. So this gives that option as well of intellectual property, whether to include it or not. So these are the 3 items, and we'd recommend that you download them simultaneously by checking the boxes of boot project and sources. For this OPC data, that's a different topic. You can leave that one checked. But it's sources and boot project. At some time, you may want to just check all of the boxes and do your download. The source can be downloaded individually. It can also be deleted. Let's look at the screen in its entirety, the download screen. The download sources box here, you can see that there's a button to delete the source if there's a source on the target. And there's also the option for the boot project to download it only, delete it only, or to activate it, simulating the power on sequence of the controller. There's also the possibility to download any type of file whatsoever, just to be stored on the flash of the controller. So why don't we try this out? Let's check the box here for include boot project and include source so that you can see what happens when these are checked. If source is checked, then there are these options below download source for user libraries and backend code. User libraries are the functions and function blocks imported into your project. We have not done that yet, so really checking these makes no difference for our project, but you would typically want those. The option here is given only that, as we know, the source can be very large and there may not be enough room for the libraries, and it would be more important then to have the main source code, and you probably already have the libraries on your computer. Page layouts is a feature that's not used by Yaskawa, and backend code is the compiled code. So let's do download here. Stop the PLC, yes. I have a warning about my cyclic task time. I'll probably have to increase that just to get rid of this nuisance message. Let's proceed. And you can see here it says I'm zipping. Now it says downloading project. Downloading source code. The download went pretty quick and the project is pretty small. But if you're looking closely, there are 3 downloads. There was the download of the project, the download of the boot project, and there's the zipping of the source and the downloading of the source. So then you would go back to your warm start. And now if you go here to the download page again, you'll see that I could delete the source on the target or delete the boot project also. And so I'll close this and close the resource window. We've also used the download changes button, and I prefer to use download changes if I'm doing code development because it does so many things at once. It makes all of the edited POUs and saves them all first. It then downloads the changes without stopping the CPU. But you do have to understand that it won't work 100% of the time because there are some types of changes that cannot be downloaded while the controller is running. One of those is any hardware change or changes in the task list are not supported. And if you don't have a project on the controller in the first place, maybe after a reboot of the controller, then it will not work either. It'll do the make, but will not do the download. And there are other limitations and reasons why download changes doesn't work. And you have to understand too that it works by memory swap. So your project must have half of the available PLC RAM capacity because the PLC is running one part of RAM. It downloads the project to the empty RAM and then at the right point in time switches over to using the new downloaded project. So as your project grows, you may get to a point where the controller just does not support download changes anymore. The amount of memory for a particular controller is dependent on that controller, and you can look in the hardware manual given by Yaskawa to see what that memory is. So I'd like to summarize what we have discussed here with this alternate diagram. On one hand here we have the flow chart showing what happens between the PLC being on and stopped running. We can use that as a reference. But what I'd like to focus on is what happens with this download and make. So here we have MotionWorks IEC, and there's a project folder. And in that project folder is the data to open the source of the project. So we open the source of the project, and at some point we click make, and make then creates that compiled project and the boot project, which is also a version of the compiled project. Then when we press download, download by itself downloads the compiled project into RAM. If we have the boot project checkbox checked, it would also download the boot project, or that could be done separately. And then the source can be zipped and saved on the flash of the controller also as zipfile.zwt. Then if the controller is turned off, when it turns back on, the boot project loads from flash to RAM, and the controller begins to run that program. But as we also know, there are different ways to start the controller running. We have typically used warm start all the time because warm start is the same as a power on for the controller. at least for Yaskawa's MPIEC controllers. But we also have cold start and hot start. So let's look at the difference between all these, because it has to do with the variables that are initialized and tasks that are run. So for cold start, which would be used automatically the first time a controller is commissioned in the field, we would take the retained variables, initialize them, initialize the non-retained variables. So in other words, all of the variables, retained or not retained, have to have some initial value the first time that the controller has a program. And so those values are loaded. There's also the option of the cold start task, which we created, and that task would run, but the warm start task would not run. So compare this to the warm start, the normal power on, where retained variables are not initialized, they're retained, and then non-retained variables are initialized. The cold start task does not run since we started with warm start, and the warm start task does run. Then under hot start, you see we have no for everything. Hot start is just a way to resume operation. So I hope this grid is a good reference and makes sense. But here, since this is training, we'd like to make an exercise out of it. And so let's do the following. Let's go into our global list and add a couple variables, 3 variables, 2 integers with the following initial values, and we'll mark var retain as retain, var non-retain, these are just the names we're coming up with, as initial value 456, and don't check the box. And then another one called var init task, and don't put anything in there. Instead, what we'll do is we have an init POU, a structured text init POU, and so you can initialize variables also in an initialize POU using this format. Use F5 to declare the variable or use the variable, and then using colon equal and the syntax, the data type pound and the value. So this method is often used to initialize arrays or structures, which we will cover at a later topic in another video. Once we have this in here, we can download changes and go into debug mode, and then you have something to experiment here to do cold, warm, and hot, and see exactly what happens in each of these cases. So as usual, it would be better if you could attempt this on your own and pause the video at this point. Otherwise, you can follow along with me or check your work here to see how I did it if you're having any trouble. Step number 1 was to add variables to the global list. So I'm not in debug mode. I'll go to the global variables list, and I'll just go up here to the top, and you can right click here anywhere to insert a variable. We want to call it var underscore retain, an integer. You can leave the usage, description, address, and I wanted an initial value of 1, 2, 3. And then here, spacebar to check retain. My next variable was called var underscore non-retain. And I'm also going to give it a value of 4, 5, 6, but not check the box retain. Didn't like that. It turned it red because I never set it to int. Okay. And then finally, insert a variable called var underscore init task. This one will be of type LREAL, LR, and it comes up. Step number 2 was to add code to the init POU. Here's init. I'll open the init POU. And to insert a variable, even if it already exists in the global list, you do need to type F5. And I'm going to take var init task. You know, I am breaking my G underscore rule here. Sorry about that. Var underscore init task colon equals, and then you type in what we call the literal L real pound 789.10, ending with semicolon. Now the training action page says we need to download changes. So it's doing a save, it's doing a make, doing a download. This message, you can click yes. And here I have an error. Let's see what the error is. It says I have a watchdog in task number 3. And I think what's going on here is it is complaining about that system tick frequency. And I believe the issue is that this simulator does not support very well these lower task times. So I think once and for all we should just change that. This is not a limitation in the IEC controllers. We're able to set the time as low as the Mechatrolink rate, the system tick rate. So we'll close the resource, go to our task list, and let's set fast here. Let's go to its settings. And instead of 20, let's go to 40. 40 milliseconds is 4 times the system tick of 10 milliseconds. So this should clear up that warning about system tick and should also keep us from having these watchdogs when we do download changes. So okay, we'll have to do a make now and a full download. Click on the error. Yes, we know. We'll stop it. We'll download it. Let's download again. So now we can leave this resource up because we wanted to see what happens when we monitor this warm start and cold start. And this is the first time we're going to get some of these types of messages. It says one worksheet could not be switched because of an unknown instance. Please use open instance to select an instance. So that means one of these tabs here cannot be monitored. And it looks like it's this one right here. Why can't it monitor the init POU? And I'll tell you why. It says unknown instance. When we opened up the init POU, we opened it up from the logical POUs, but init is running in 2 tasks, the cold system task and the warm. So what it's telling me here by that message is, well, how do I know to tell you what happened when it ran in warm or when it ran in cold? So since we don't know which task you want to monitor, you better open it again. So that is exactly what we'll do. And then if we go here to open init, it asks me, do I open the cold instance or the warm instance? Why don't we open up the warm instance? And now we can do a warm start. And you'll see that at warm start, it ran this and applied the value 789. And this point is being illustrated here in the documentation for the class. And what we'd like to do next is to take a look at the global variables, make some changes online, and then make some predictions and see if you can understand what happens when you do a cold start, warm start, or hot start. So back here in my code, let's look at the global variables and let's see what happens. Let's change each of these. Var init task, you can double click right here. And let's put in that value work, 0.08. Var non-retain. Let's put in a value of 10. And var retain 10. 10 was remembered from before. So what should happen now? Let me arrange this here a little bit. It is possible to move these columns here. What should happen if I press stop now and run a cold start? Try to predict what should happen. Which values will be applied with their initial value? All of them. Plus the cold start task ran. And in the cold start task is where we have the init that does this line right here. So let's set it up again. And let's overwrite these variables again. Say the code is running and the variables get overwritten by the operation of the code. Let's do a stop now and a warm start. Now what should happen? Let's try it. And you see that the retained variable retained its online value. It did not apply the initial value. But the non-retained variable did get initialized. And since that init task ran again, because we put it both in cold and warm, it ran again and the online value was applied to the var init task. Let's set these again. And let's try now this stop and hot start. What should happen on hot start? Nothing, because none of the data should be changed and no tasks run under hot start. So I hope you can see by this hands-on example what the difference is now between retained, non-retained, and what happens when you put a variable to be initialized in a task that runs with cold and or warm. So if we could focus our attention on the question at the bottom, why do you mark a variable retain in the first place? What application does that have? And as we're mentioning here, home offsets, part counters, basically any variable in your controller that should keep the value when the power is off. You may have gone through to do a complicated homing sequence to determine an offset, or maybe the controller has been running for an extended time and you want to track how many parts have been created by this controller, or you want to have an idea of how many hours a system has been running in order to program any scheduled maintenance. And so these are some practical reasons why some variables have to have their values retained when the power is off. And just so you know how this happens in our MPI-EC controllers, is there's a little battery in the controller, and that 3.6 volt lithium battery is powering the RAM and saving the values of those variables that are marked retain. Now, as the final topic, I would like to examine what we call the power on sequence for the PLC. Let's put all this together. We've gone through making and downloading and executing, but what exactly is happening at a power on? The first thing that happens is you load that boot project from flash to RAM. We've illustrated that. Then you would normally do a warm start in which variables are initialized. The warm start system task runs, and then it goes on to running cyclic tasks. For the simulator that we're using here in this training, there is really no power on button. So instead we have to go through these stages manually and separately. So let's run through this as a timeline here, where we are working from left to right, and then either to do a warm start or a cold start. I put all the pieces together here. Now, a real PLC does have to power up and get all the circuits up and running and load whatever it needs to load. That is not part of the PLC simulator here. But once it is on, the first step is to take that boot project and send it into RAM. So we could simulate that here. We could stop the PLC. When the PLC turns on, it's then ready to do its activate its boot project. So we could do that. Activate the boot project. And as it shows here, it says the currently loaded program will be overwritten by the boot project. So we'll click yes here. Now it says no project on PLC, debug mode not possible. Based on the last question, we told it yes, wipe out the existing program and load the boot project. So let's just click OK for this. And you can go back in here to debug mode now that the boot project has loaded. Okay, so that was loading the boot project into RAM. And then, in a sense, the controller asks a question. Is this the first time that this project has been run on the controller? And normally the answer is no. No, it's been here before. We have even variables retained already that match this project. And so we can do a warm start. What are the steps to a warm start? The first step is to initialize any of the non-retained variables. The second step is to execute the warm start task. And then finally, go into this cycle of doing the tasks in the task list, the cyclic tasks in the list, including the system task, which you don't really see in the list, and also the reading and writing of IOs according to the tasks that they're assigned to. So all these things then happen in their cyclic manner, and then this is the normal operation of the PLC that goes on virtually without end. And alternatively, after PLC power up and loading that boot project to RAM, if it's not the first run, Then cold start will be performed by the controller. All data will be initialized, retained and non-retained. Then the cold start task will be performed. And then it will go into the cycle of system read inputs and outputs and doing the fast, slow, and any other tasks that you have configured in the system. So I hope that this explanation has shed some light on what's going on in an IEC controller. Up to now, we had been concentrating only on the tasks operating in the final steady state stage, if you might call it that. And we hadn't talked much about the warm and cold start task. But now I hope you understand what's going on with variables that are initialized, tasks that run, and the whole concept of the boot project being loaded. And I might ask you some questions here, such as where does the source come into play? And I think you can see on the diagram that it has nothing to do at all with the execution of the code. The project source is not required to run the controller, and the project source may not be on a controller. Any IEC controller does not have to include the project source. It's just another file that is there for your convenience. And with this, we'll conclude program data transfer.